Okay, I'm going to do a heats of formation problem and show the skill for people who may have missed the lecture the other day that Mr. Thomas gave. What is a heat of formation? The heat of formation is the heat that is released or absorbed when 1 mole of a molecule is made from its elements. Now, we're not telling you right now where it's used. We're going to get to that, and it is extremely important in this unit. But what you have to do is take a molecule, so we'll do 3 examples. We'll do CO2 gas. Now, this is important here. You need to know what the state of the product is, and we'll explain why in a few minutes. And you have to make this from its elements. The elements are carbon and oxygen. Now remember, it's not O, it's O2. There are certain elements on your periodic table, and you should have this written in your periodic table, H2, N2, O2, F2, Cl2, that are always 2. Sometimes Br and I are 2, but that'll be given in the problem. Then what you do is you go into your exam package, you look up heats of formation, and you will see a chart, and then there's carbon dioxide gas. Every state will have a different heat. And when you look that up, the delta H for CO2 gas is negative 393.8 kilojoules per mole. In other words, if we burn or if we react 1 mole of carbon with 1 mole of O2 and it makes CO2 gas, we will release that much energy when the molecule is being formed. Let's do a second one. Let's do H2O gas. You write down the molecule they're asking you to form in the question. You look up the elements. It's H2 and O2 to form this, and you have to balance the reaction. 1 oxygen on this side, what times 2 will give you 1? The half will. Okay? Then you go to the enthalpies of formation chart and you look up the value, and I believe it's negative 241.8 kilojoules per mole. So that says negative 241.8 kilojoules per mole. Now some people may have panicked when I balanced this way using halves. So let's do this one a second way. H2O gas, and then we've got H2 plus O2. Let's say we've got 2 O's here. So now we've got 2 O's there. 4 H's there. Now we have 4 H's there. Here's the problem with doing it this way. If you double this, you have to double this amount right here. Okay? So you've got to make sure that it's negative 241.8 times 2 is your value here. Listen, if you double the O, you don't do anything here. If you double the H, you don't do anything here. The definition of a heat of formation is it's for 1 mole of the product. So if you have 2 moles of the product, you have to double the heat. So remember, whatever you do to the product, you have to do to the heat. Last one. Write down the molecule. This is glucose. The delta H, if I look that up on my sheet, is negative 1273. You can also use your Google machine to get answers. So if you say, hey, what's the heat of formation of solid glucose? You should get a number. What are all the elements? Every time you get a capital letter, you've got a new element. C, H, and O. Don't forget, 2 of these elements are diatomics. The rest are not. And now balance. 6 carbons here. You can only balance by putting numbers out front. If you put numbers down below, you're changing the molecule, so it's no longer carbon. H12, what times 2 gives us 12? 6. And we've got O6, what times 2 gives us 6? We have 3. That's how you make heats of formation. Let's see how it's used. Let's say we have a Hess's law problem, and we're trying to find the heat of this reaction. Let's say that they give us 2 things. Now, I'm just going to put fake heats in here just to get us rolling. Let's say that CH4 is negative 200. I just made that number up. Let's say H2O is negative 100. Let's start doing the problem. I always say, find your molecules and make sure they're in the right place. This one's not, so we're going to have to flip this one. Find the molecules and then make sure they're in the right place. So this is on the product side, this is on the product side. Hey, this is good, but we don't have enough. We've only got one, we need two. So we're going to multiply this by 2. Now, where is this molecule right here, the CO2? It's not there. If it's not there, we know how to make a reaction up. We remember, or we could see up here, that the heat of carbon dioxide is negative 393.8. Okay, here we go. I am going to multiply this by 2. I'm going to multiply this by 2, and I'm going to multiply this by 2. I now have 2 of each. This one I'm going to flip. So I'm going to go CH4 goes to C plus 2H2. If I do something, if I write it out again, I make sure I scratch it out so that I know. This will tell me what I have to do with the numbers at the end. Let's see what happens here. Let's see what happens here when we try to add everything up. First of all, what don't I have up here? This is not right. That half's not supposed to be there. It's C plus O2 gives CO2. You got to be careful when you do these or you make sloppy errors like I do. There's no H2 up here. That means we should be able to cancel out our 2 H2s on both sides. There's no carbons here. There's 2 O2s there, 2 O2s there, added up. I see a CH4. I see 2 O2s. They're on the same side of the reaction, so I add them. I've got a CO2 and I've got a 2H2O. The biggest error that can happen in these problems are sloppy errors. Watch for this. Now what I have to do is I have to reverse the sign on this because I flipped the reaction. I have to double this one because I doubled the reaction. And now I add 200 plus negative 200, so they would actually cancel out and we would end up with negative 393.8 for our heat. This is just working through a problem of where you would use one of these heats of formation in a Hess's Law problem.